Hey everybody, it's Dr. J, and today we're talking about Le Chatelier's principle. Let's talk about chemistry. So Chatelier's principle is basically when a system in a state of equilibrium is acted upon by some outside stress, the system will, if possible, shift to a new equilibrium position to oppose the effects of the stress. So basically, if you add a little stress to your system, it's going to change it to a whole new equilibrium. Okay, that's basically what this is. So, what exactly do we mean when we say stress? So, stress means that you're about to disturb something, right? You're about to cause me some tension to something, right? You're about to do something that I'm not going to like, right? So, this is stress. And because we are disturbing the reaction, right, it's going to have to shift to an entirely new equilibrium because you just stressed me out. Let's talk about some different stresses, right? So either you can add or remove reactants or products. You can increase or decrease the temperature. You can increase or decrease the pressure. And this is only if gases are being evolved. So once you do one of these different things, the reaction will no longer, right, be in equilibrium because you're changing it. You're changing the environment. And because you're changing the environment, we're going to have to shift to a new environment, right? So when you have to shift to a newer environment, then it's going to shift back to a new state of chemical equilibrium. So basically, we look at this example here. Say I got A plus B giving me C and D as my products. So the original reaction is currently in equilibrium. But let's say we add a stress to it. In this case, let's say we add some more products, right? One of the stresses that could be done here. So let's say I add more C. And now the reaction is like, oh my God, it's too much C right now. It's too much C right now. Okay, so it's too much product. What do we have to do? Well, we're going to have to readjust to get back to a new equilibrium. So in this case, the reaction will shift backwards to consume some of this extra C now. So in this case, the reaction is going to have to make more products to get to this new equilibrium, right? Because once again, we're trying to get our rates to be the same here. And if you're adding more C, you're changing up the rates now. Okay, you're changing up the environment. So this is how we're going to be thinking about this principle, right? If you add a stress, it's going to change the equilibrium and shift it to a new equilibrium position. So I have laid out basically 4 different ways that adding or removing products are going to impact your equilibrium. All right, so let's talk about adding. Let's add. So if we add products, right, to a reaction, then our equilibrium will shift to produce more reactants, right? So understand, just as we mentioned with C, if you add more products to one side, we're going to have to shift the reaction, right, going towards the left because we need to make more reactants to get us back to this equilibrium. If we add more reactants, right, to our reaction, then we're going to have to shift, right, forward to make more products, right? So the more reactants we make, more products we're going to have to shift and balance each other out. Now, one thing I will say, right, remember, if the product is a solid or if the reactant is a solid, if you're dealing with a solid at all, it's not going to impact the equilibrium, right? Because it's heterogeneous equilibrium, what we talked about. Pure solids, pure liquids have no impact. Now, if you remove a reactant, all right, if you remove a reactant, this is going to cause our equilibrium to have to shift back to produce more reactants. Okay, so if you take away a reactant, all right, we need to replenish those reactants you took away from me. If you remove a product, right, then it's going to, once again, cause the equilibrium to shift to produce more products. So you take away some products, I need my product replaced. So I need more of that back here. Okay. So that's basically what's happening, right? Whatever you take away, that's going to come back in full. And depending on what you add, Well, the opposite is going to take place here. So if we look over here, let's look at this example. Let's say I got N2O4 giving me 2NO2. All right, and we can see right now, I got my NO2 and N2O4, going around. And it's currently at equilibrium, so it's done. All right, the reaction's over. Let's say, though, I decide to add more NO2. I decide to add more products. So let's look at this. If we add products to a reaction, it's going to cause our equilibrium to shift back to produce more reactants. So now my equilibrium is disturbed. So what's going to happen? Our reaction is going to shift towards the left. Now it's going to shift towards the left, right? So basically what's about to happen is it's going to consume some of this extra product we just put in place here. So when it consumes some of this product, now we could go backwards to make our reactants to get us back to an established new equilibrium. So this is what's happening here, right? Shifting back left and consuming our NO2 up here. So there's one other thing I will mention here. The effect of temperature on a reaction is dependent on whether the reaction is exothermic or endothermic, okay? So remember, exothermic is when your delta H is negative. Endothermic is when it's positive. We're going to talk about that in a little bit. But for now, just focus on adding or removing reactants. Let's move on to the next part. So this is just another graph showing this. Again, N2O4 gives me 2NO2, right? And we need to understand a couple different things. So as we mentioned before, if you add NO2, if you add products, your reaction is going to have to shift left. And this graph is kind of showing that, right? To where basically original equilibrium, so we're at equilibrium, Q is equal to K, etc. Everything's good. We add our product, so what's going to happen? Our concentration is going to go up because we're adding product, which we see here. Because we add product, now our equilibrium is no longer the same. It's going to be different, right? So therefore, we need to be reestablished here. So same concept right here, down here. If we look on the other end, though, right, if we add our reactant, what's going to happen here? Well, our concentration will change, right? So now our equilibrium needs to be reestablished. So if you add a reactant, then we need to shift right to make more products. And you can slightly see, right, with our NO2, it slightly went up to make more products. Because, right, we had to reestablish our equilibrium. And even if you look right here at the N2O4, right, even though we added N2O4, guess what happens? It slightly dips, right? And that's because it's going to be consumed. This N2O4 is going to be consumed to produce more NO2. Even on the other side, we can see these slight dips, right? When we added NO2, right, it slightly dipped because we had to consume some of that extra product to make our N2O4. And then we can see, right, it slightly goes up, right, from the initial equilibrium to reestablish our equilibrium here, our new equilibrium, okay? So this is what we're talking about, right, when we're talking about adding or removing products or reactants for Le Chatelier's principle.